Okay guys, let's take a look at our Polar Day 4 lesson. I'm going to have to switch back and forth between the calculator, so it's just a little bit messy, but I think we'll be fine. Alright, so our question, and just let me kind of preface it by saying this particular question is styled off of a AP free response question on Polar. So this is a type of questions that you would get on the AP test in this day's lesson. Alright, so what we have a curve drawn in the XY plane, and it's described by the polar equation, the equation in polar form, and the coordinates are r equals 2 plus sine 2 theta. Notice that we are restricted. That's a pretty important thing to notice. We're restricted from 0 to pi. And so r is measured in meters and theta is measured in radians. Okay, so that's the setup. Sorry, I had to flip back and forth. So what we're going to do is we're going to sketch the graph of the curve on the calculator. And so let's take a look. Alright, hopefully you remember how to put your calculator in polar form, but if you don't, well, you can just walk through with me. We would go to our mode, and we would make sure that instead of in function mode, we're in polar mode. We also need to make sure that our angle measures are in radians, not degrees. So your screen should look like that. Another thing that we have to account for is our theta is restricted between 0 and pi. So I would go to my window, and actually it is restricted at pi right now. And the normal restriction is 0 to 2 pi. So you need to go in there, it's at 0, we would change our maximum theta to pi, and then we would be good to go on graphing. If you don't change it, then you will probably get a different graph than it's intending you to get. So you need to be sure to do it just like that. So then we graph it. Oh, and let's put the equation in. So the equation is 2 plus sine 2 theta. So 2 plus sine 2 theta. And now we graph it. And that's the kind of graph that we have. So I'm going to go over, let's go ahead and graph that on here. So it looks like it starts at 2, then it comes out, goes, looks like it crosses through at 2, and then does kind of a little squiggly thing and comes down to 2. So that's our sketch of the graph of the curve. Now, just for curiosity, now maybe none of you are curious, but just for curiosity's sake, I want to show you what would happen if you left it on the default, which is 2 pi. You see we're going to get more of the figure than they wanted us to have. See how it comes down here? They don't want us to have that part. And so if you graphed that part, you would get it wrong, because they're asking you to restrict it from 0 to pi. So I'll go back and restrict it. Okay, so that's the proper graph that we should have. Okay, so that's graphing. Let's go ahead and let's look at the second part of the question. The next part says find the area bound by the curve in the x-axis. So luckily, I mean, we really have our bounds are already set from 0 to pi, so we don't have to figure that out. We just use our formula for half r squared. So we say 1/2 integral from 0 to pi of 2 plus sine 2 theta squared. And now we have our calculator available, so we put this in our calculator. So a couple of ways that I could do this integral. I'm going to choose to do math 9. And if you want to, you can go ahead and insert that 1/2 so you don't forget it, or you can just at the end divide by 1/2. or divide by 2, excuse me. So we're going from 0 to pi. And we need to be sure to put an extra set of parentheses in here because we're going to be squaring that. And I don't know about you, but I would rather have the calculator square it than me because I might make some kind of a sign error or something. So let's just let the calculator do it since we have use of it anyway. Okay, so we have the 2 theta in parentheses. Then we have the whole thing encased in parentheses. The 2 plus sine 2 theta is encased in parentheses and squared. And then we put in our theta. And hopefully I have the right number of parentheses. 3. And there is our area. Now notice that I'm still in polar mode. I would not have been able to do this on the y equals the graphing screen. You know, some of us like to use the graphing screen to do integrals. The graphing screen for polar is quite limited on the things that you can do. So you would not have been able to work this in the graphing screen, but it certainly will work just fine on the plain, you know, just the blank screen. So then our answer, we would put 7.0685 meters squared. And so that's the area bound by the curve. All right, the next part says find the angle theta that corresponds to the point on the curve with the x-coordinate of -1. X-coordinate, I mean, this is kind of alarming to students. We don't have an x-coordinate. All we have are r's and thetas, so what in the world are they wanting us to do? This comes up from time to time, and really what they're wanting you to recognize is one of the formulas that you would have learned in pre-cal, and that is x equals r cosine theta. So that really is the template that we're going to use to answer the question that they want. So we would write our formula down, x equals r cosine theta, and the x value they say is -1. And our r was given to us up here, so r is 2 plus sine 2 theta, and then our cosine theta is from this portion right here. So we have set up our equation, -1 equals 2 plus sine 2 theta times cosine theta. Now we could have done this if it had said y-coordinate. So if they wanted the y-coordinate, what do you think we would have done? Yeah, we would have used the formula for y, which is y equals r sine theta. So we could have just easily have done a y-coordinate as an x-coordinate. They're just asking for the x. So now that we have this written out, we really do not want to solve this one by hand. So we want to use our calculator to solve. Okay, I am going to use my calculator to solve this, and this was troubling people earlier today. I really need you to be with me here. Yes, we understand that the -1 represents the x and the theta is an angle measure. But when I use my calculator to solve, the technique that I like to use is the y equals in the function mode. That's what I like to use. Now, a lot of calculators have the equation solver. I've played with it a little bit. I'm not comfortable with it. I haven't quite figured out how to use it, so I go back to my old standard, which is intersecting. No, this -1 is not a y. I'm not saying that it is. I'm just using my calculator to solve for a variable. That's all. Are we clear on that? I'm not really trying to get any meaning beyond just finding out what x is, or theta. Alright, so I'm just using it as a solver. I'm not setting, you know, y equal to -1 for any reason. Is everybody okay with that? That was really confusing people earlier. I am not using the variables in the way that the calculator is. I'm just using it as a solver. That's all. And to use it as a solver, I have to be in function mode. The polar mode is quite limited on the number of things that it will do for you as far as calculations. It won't do integration for you. It won't do intersections. It won't do quite a few things. So I actually need to go back to function mode just so that I can use my solver. That's all. That's how I solve. And then we go to y equals. I'm going to put the -1 in y1, not because it's a y, just because I'm using it to solve the equation. And on the right side, I'm going to put in 2 plus sine 2 theta. It's okay that it's not a theta. Again, I'm just using it as a variable. I'm using it as a solver. Okay, the variables don't have to be exactly perfect. I'm just solving. Okay, and so then let's make sure I have all my parentheses on here. I think I do. So 2 sine 2x is encased in parentheses. Then I have my, okay, it looks good. So we graph it. Notice that I've got a lot of intersections, so I need to think back to my restrictions. My restrictions, it restricted me from 0 to pi. Pi is like 3.14, so I'm thinking that this intersection is the one that I need. That's the one that I'm looking for, so I do second calc. I go to my intersection. I scroll over to the intersection that I want, and then hit enter, enter, enter. And that is my theta value.
We're going to get a theta value of 2.6303. And that would be in radians, so we can leave it like that, or we can write radians. Alright, great. Now that is the first 3 prompts. We have a couple more to do on the other page, so let's go to the other page. And let's look at this one. It says, find the value of dr d theta at the instant that theta is 5 pi over 7. What does your answer tell you about r, and what does it tell you about the curve? Okay. So they want us to find dr d theta. Well, this would be one of the things that your calculator would be able to do for you. If you'll recall, there's only like 3 things in the polar mode that you can do. One is to find a value, one is to find dr d theta, and the other one is to find dy dx, which is a very handy. If you'll recall, the formula is quite intensive. So let's just use our calculator. We're going to find dr d theta at 5 pi over 7.
I'm going to let my calculator calculate my derivative. That's what I'm going to do. It's one of the few things that it'll actually do in polar form in the graphing part. So I'm just going to go. You could do it on a blank screen also. I already have the equation input into the polar, so I'm just going to go back to polar and let the calculator find my derivative for me. So I already have my 2 plus sine 2 theta in there. And if I look at second calc, I mean, those are the only things that the graphing in polar allow you to do, is find a value, do dy dx, which is kind of nice, right? Dy dx is that really big formula. It lets us do that with the calculator, or dr d theta. We want dr d theta. So we want to do number 3. So second calc, number 3. All right, we want, now I would suggest that you put the numerator in parentheses. It really shouldn't matter, but for me, and sometimes it has. So I would just to be on the safe side, just put the numerator in parentheses, divided by 7, and that's going to give us our derivative value.
Negative 0.44504. Now it says, what does your answer tell you about r? Well, now we just found the derivative of r, and it's negative. So let's think back to our work with functions and derivatives. When we had a negative derivative of a position, what did that tell us? Yeah, that told us that the function was decreasing, and it tells us the same thing here. So we would say, since dr d theta is less than 0, r is decreasing. Just like when we were working with functions, it's the same kind of meaning. Now the next question, what does it tell you about the curve, is a little more intense. It's like, well, you just asked us about, what does it tell you about r? What does it tell you about the curve? So what they're really wanting to hear here is they're really wanting you to describe the curve in relation to the pole or the origin. What is it doing? Is it getting closer to the pole or is it getting farther away from the pole? And so since r is decreasing, then it's actually, the curve is getting closer to the pole, and that's really what they're asking. It's kind of a code. It doesn't say anything about what its orientation is to the pole, but that's exactly what they want to know. So we would say that the curve is getting closer to the pole. And you could also say origin if you didn't want to say the pole. And that basically is what they want. All right, let's look at our last part. The last part is where we get to mix up particle motion and polar. Yes, that does sound exciting. So that's what we're going to do. We're going to mix up particle motion and polar. Let's see what they want. We have a particle is traveling along the polar curve given by r equals 2 plus sine 2 theta, so that its position at time t is x of t, y of t, and such that d theta dt equals 3. Okay, that probably is important. Find the value of dx dt at the instant that theta equals pi over 6, and interpret the meaning of your answer in the context of the problem. Goodness, they want dx dt again, and we don't even have any x's in here. So that brings us back to our same problem we had on the other part of this question, and that is we've got to introduce the x variable into this problem. So we do what we did before, which is use our definition, x equals r cosine theta. Alright, so r we were given is 2 sine 2 theta, so x equals 2 plus sine 2 theta times cosine theta. Alright, and we want to take the derivative with respect to t. Well, we don't have any t's in this. So now that should bring you back to our work with related rates. If you will recall, a lot of those equations we didn't have t in either. And the way we handled it is that we tagged each variable that wasn't a t. And that's exactly what we're going to have to do here. We're going to tag each variable that's not a t. So the derivative of x would be dx dt. Now this is a product, so we've got to do fg plus fg, first things first, second things second. Alright, so the derivative of f, which is this first function, derivative of 2 would be 0. Derivative of sine 2 theta would be 2 cosine 2 theta. And I just took the derivative of something that wasn't a t, so I tag it with d theta dt. Then I copy paste the second piece, which is cosine, plus. Now I copy paste the first piece, which is 2 plus sine 2 theta. And now I take the derivative of the second piece, which is cosine. The derivative of cosine is negative sine. And I just took the derivative of something that wasn't a t, so I tag it d theta dt. Now, this is how we would do it by hand. We would go ahead and sub in a pi over 6 everywhere we had a theta. These little pieces right here, these we know are 3. We know that from this piece of information right here. So we would just work that out by hand. But since we have a calculator, let's investigate how would we do this with a calculator. So let's think about this for a second. The reason that this is a bit more tricky with a calculator is because of this implicit differentiation. Notice that I have a d theta dt in both terms. And so could I factor this d theta dt out and multiply the whole thing by 3? Yeah, sure I could. And that's basically what we would need to do if we were going to use the calculator, which we're going to. I'll show you how to do that. We're going to let the calculator calculate this piece of it, the dx dt piece, and then we're going to multiply the whole thing by 3. And that's going to give us the answer that we need.
I want the calculator to do this for me. I have some options to do the derivative for me. we could stay right here and let it do the derivative for us. Okay, I need to put the cosine on there for me. So I'm going to insert a parenthesis here. Okay, so now I have 2 plus sine 2 theta by itself. And now I'm going to put cosine theta there. Now, I want you to think about this. Please don't get caught up on the dx dt. So what I'm really doing is I'm going to find dx dt and I'm going to multiply it by 3, right? I mean, that's what we just decided. Well, this isn't an x, it's an r. And this is a theta. Yes, it's a theta. So which derivative, if I'm going to, again, we're going to equate variables. We're going to pretend that that r is an x. Okay, but it's really an r. So when I go to do the derivative, which one of those am I going to use? The dr d theta. That's the derivative of the thing that's there. That's what I want to do. I want to take the derivative of the thing that's there. So I'm just using my calculator as a number cruncher for me. The variables don't have any meaning for what I'm doing here. So I do my dr d theta, and I'm going to do that at pi over 6. Okay, so that's my value.
And that's going to give us negative 0.5669. And then what we're going to do is we're going to take this and we're going to multiply it by d theta dt. So we're going to multiply this whole thing by 3. And so therefore our dx dt is going to equal negative 1.7009. Okay, and that lets us, the calculator, do the work for us instead of us doing it by hand. And if that troubles you, I promise you, if you work this out by hand and plug in the pi over 6 and do all that, you will get the same answer of negative 1.7009.
Now, it wants to know, interpret the meaning of your answer in the context of the problem. What does it mean when dx dt is negative? What does that mean? What is the x in our vector, in a vector valued function with the x, y? What does the x part mean? Horizontal movement, right? And so if it's dx dt is negative, then our horizontal movement is decreasing. It's negative, right? The horizontal movement. And that's what it's asking us. Okay? All right, over time, dx dt.
All right.